Alright, so once we've done this step over here, the subsequent two steps are hydrolysis of the added cyano group, which is right here. So then we get to this molecule. So this was addition at this point of this cyano group. And then the question is, what's happening as we go from here to here? And we talked about this, we actually discussed this in lecture also, is that I think the important way to think about this is, so draw this as the carboxylic acid, and then draw this as the enol form of this carbonyl, and then these two are going to come together through Fischer esterification. And that's what's going on right here, is that these steps, I'm not going to go through the details of these, but these steps are facilitating this Fischer esterification. What you're doing here is you're taking this and making an anhydride out of it. Okay, so again, this is the same step, just repeated over here. So then I also went through this step in class, which was methyl magnesium bromide. You have a methyl, it's going to attack right here, undergo nucleophilic acyl substitution, and then the resultant product out of that is going to be, it's going to look like this. Let's see if I have enough room over here. So again, so if that wasn't on film, so this methyl group is undergoing nucleophilic acyl substitution at this position. So we'll draw part of this. Right, so this enol becomes this ketone. This methyl group that undergoes nucleophilic acyl substitution here becomes this methyl group. And then this closes right here through aldol condensation. So going from here to here is the aldol condensation product. Okay, this is an acid. This is periodic acid. So you can also see this as NaIO4 sodium periodate. So this is two things. Because it's periodic acid, it will, so this is an acid catalyzed removal of this acetal protecting group. But in addition to that, there is chemistry that, again, was discussed in a chapter. We didn't go through it in great detail, but when you have a situation like this where you have two cis vicinal hydroxyl groups, so the product of this is two hydroxyl groups, is that when you treat it with sodium periodate, it will actually cleave this double bond to give you the dialdehyde that you see right here. And so what you're doing here, hopefully you can see, is that you are going to undergo enamine formation here. And then the resultant enamine will create a nucleophilic position here that will undergo condensation at this position. Alright, so that's the purpose of this, is you have an enamine formation to that. You're left here with this group. You're going to oxidize this to the acid, and then you're going to esterify it. This is a very specialized reagent for generating methyl esters of acid. So this first step is to take it to the acid, and then this reagent, I'm not going to go through, it goes through a reactive intermediate called carbene, which I chose not to discuss because, again, it tends to generate more confusion than it facilitates. So then the next step is hydrogen on platinum. So the platinum is a very active catalyst, and it actually does a couple things. So it will hydrogenate this bond, and this bond. And it's actually so active that it will convert this. So it will add hydrogen across this carbon-oxygen double bond, which is a reaction that we haven't seen yet, but you can sort of think of it mechanistically as it happens the exact same way. And then you oxidize it back up to the ketone. So that's what that step is right there. So I need to start a new video because of size.